I hope my screen is shared. You can see things. So, good morning, everyone, and welcome to the first session of Golang. Some people are asking for the access. Okay, so first session of Golang. So, in order to write Golang applications, you should have a code editor. So, Visual Studio Code is the code editor. I think some people use even uh, Goland. There is a code editor. ID is something called Goland. Some even write, Vim also we can use if you know about Vim. Basically, Visual Studio Code has become a quite a standard for the most of the Golang projects. And then you need to install Golang. If your Go is not there, you need to install Golang. So go to go.dev. Once upon a time, it is golang.org. I think it has moved to go.dev. This is the website from where you have to download and install Golang. I don't think there is a problem for you to download. I don't need to explain how to download. Just go and then click on download. It gets downloaded. So I'm using MacBook ARM machine. So this got to be my download. This gets downloaded on my machine and then it gets installed. Fine. Most probably a little bit of theory is there today. So let's take its own time, but let's come back to the pre-install detected already because I think 2 version 1.26.2 version is already there in the machine. So I am trying to install the latest version of Golang. So generally, I started my journey with Golang with the Go 1.0.2, I guess. 1.0.2, 2012. I guess during 2012 when I was working for Emirates Airlines, I started. This got to be the directory I have created. Let me go to the GitHub, github.com. There are so many repositories with respect to Golang for me in GitHub. Uh, May, June 2026. Yeah, this is the repository. It's a public repository. I created this repository. So I hope you know Git related stuff. Git init. I'm initializing it as a Git repository and just a copy paste from here to here. It has copied and nothing to be pushed. So let's keep it like that. I got to open this. It's a workspace. Go to trainings. Sorry. It got to be the so this has been added over here. Fine. So you know that Go is a programming language, and obviously, in order to work with a programming language, you need to write programs. So let me get started with a question. There are so many programming languages out there. There are so many programming languages are there. There is a Java, there is C Sharp, there's Python, and then there are various versions of various flavors of functional programming, object-oriented programming, procedural programming, something like C. Uh, and why Go is my question. Why Go is why Go? Why do you want to use Go? Or why does an organization would like to use Go? This is a basic question. Why Golang? Uh, is a basic question that we need to answer before going to jump into Golang. Understanding Golang. Why Go? What is the difference between uh, if you differentiate? Let's take one system language, something like system language. You can take C, or object oriented. You can take Java. Okay, and then interpreted. You can take C sharp, sorry, JavaScript or Python. Let's take Python. Functional, probably you can take Lisp or Closure. You can take Closure, something like function. Like that, there are programming languages for each and every category which are very popular. You can take Java or C Sharp. Okay, you can take Python or Ruby. You can take Closure or Haskell. You can take C or even system programming language, Rust. Like that, there are different flavors are there. I mean, different programming languages are there everywhere for every concept you take. System programming is writing systems up, applications that talk to the system. System can be operating system. Object-oriented programming is something like each and everything that you program, you classify it and then you create it as an object. Interpreted means which are have become very popular. There is no special compilation process, but there is directly an interpreted process. Line by line is compiled and then it gets run. Application would run. Functional programming is something like, you know, functions are the first class citizens. That means everything you do with the functional programming, you do with your domain, you create functions. Functions are the first class citizens. Okay. These are the things. Where does the Go fit into? Why Go? These many are there. What Go is going to bring? Okay. If you really look at various kinds of programming languages, I will add a note separately. I just write it over here for your understanding, but I will properly format and then make it as a Markdown file and then create notes. Please don't worry that this doesn't look properly aligned. May not look that great, but it's okay. So why Go is very important. Okay, so you need to understand what is Go. Go is general purpose. General purpose means Go is not designed to solve one specific problem. Go has been designed to be a general purpose programming language. Go is compiled. You know that compiled programming language means there is a compiler. You write your application, okay, there is a compiler. You compile your application, it gets compiled to generally some programming languages, it gets compiled to an intermediate code like Java bytecode or C sharp ML code, intermediate language IL code, or Rust LLVM front end. But co-compilation is quite different. Okay, I will discuss about this. What is compilation, how the compiler work, a little bit at a high level, I will explain with Go. So Go is a compiled programming language. They say that Go is a systems programming language. Go is also systems programming language. So here the question comes, what is called system? Can you really do operating systems? Can you really create operating systems with Go? The answer is yes or no. But why do you call it as a systems programming language? Go is considered to be a systems programming language. When you call it as a system, you are not maybe probably not talking about operating system. You're talking about a system, something like Kubernetes. You're talking about a system, something like etcd. You're talking about a system, something like a Docker. These are all also called as systems. Systems can manage their resources. Systems can isolate certain things. There is a life cycle for every system. System starts and then maybe system ends. Systems can create components so that the communication can be established between the components. There is no a specific meaning, a specific single word for a system. System means something that has its own resources and then those resources can be managed. So Go can be considered as a systems programming language. The generally what we think is system is only an operating system. No, system is not operating system. System is something that can manage the resources. You can think of immediately Kubernetes as a completely written in Go. Docker has been or containerized systems are written in Go and etc. So Go is a systems programming language. Go is compiled programming language. Where does Go fit into? Is it in if you really look at this, interpreted, functional, object-oriented systems programming. This systems programming is different. This is different. This is the feature. This is specially designed for C and Rust are specially designed for systems programming. Here I'm talking about a feature. So don't be confused between the systems programming over here and then systems programming over here. Right. So where does Go fit into? We can do systems programming, as I said earlier. Go doesn't encourage object-oriented programming. Go doesn't say that everything that you create it as an object. No, classify it. There is inheritance. There is a polymorphism. Okay, uh, kind of a thing. There is multi-level or multiple inheritance. There is a polymorphism, etc. These things are not there in Go. Go doesn't encourage inheritance. Rather, Go uses composition. If you know about, there are two things: composition and then inheritance. We'll discuss about that. So where does Go fit into? So what I found is Go is kind of a hybrid. Go uses a hybrid paradigm. So hybrid programming language. Okay, what does it mean? Not oops, not functional, not systems. You can think of Go is kind of a hybrid programming language. Okay, fine. What else? Who created Go? Go was started in 2006. Go was started in 2007 by engineers at Google. One of very famous engineers is Rob Pike, Ken Thompson, and Robert Grisimer or something. Particularly, I want to mention this name. You can see Rob Pike videos. Those are very, very famous videos. Rob Pike is not only inventor of Go, he has done a lot of work on something like a Plan 9 operating system many years ago in 1980s. Plan 9 operating system he has done. He has contributed a lot to Unix Foundation. So Rob Pike is a very well-known face in the industry. I encourage you to go and then watch his videos as well. You understand, who is Rob Pike. His explanation towards many things with respect to Go. You can see Rob Pike, his dressing is also very different, particularly Rob Pike Golang. Uh, you can see that's glazing dresses he use. Maybe I don't know why it is, but Rob Pike talks about Go. Simplicity is complicated. Parallelism is entirely different. There is a he used to attend a lot of conferences. Concurrency is not parallelism, which is one of the best talks about Go. He is one of the main inventors of Go. I encourage you to go and then listen to his videos. Maybe one of the famous videos is concurrency is not parallelism. That is one of my, you see, this one. Concurrency is not parallelism. So my first attempt to understand concurrency in Go was, after listening his video. My first attempt means, yes, I was using Go, but even then, I wanted to know what is really the difference between concurrency and parallelism. Back a decade ago, he explains very, very clearly concurrency is not parallelism. Ropai, please, when you get a time, just please go and then have a look at his videos. Maybe that one video can change your perception towards concurrency and parallelism. I will explain more about it. I understand. Okay. So basically, this is what Go is not a object oriented, Go is not functional, but you can do everything with Go. Whatever you can achieve through object oriented, you can do with Go. Whatever you achieved with the system programming languages, majority of the things you can do even without, talking to the systems. If you know kind of assembly language, functions are first-class citizens in Go. Functions can be created as variables, stored inside variables, passed as parameters, used as our parameters, and then passed as an arguments. Functions can return functions. Function can be a type and then can be attached to your method. You can do whole lot of things with functions. Can you do functional programming? Yes, you can do. Is it a pure functional programming? No, it is not pure functional programming. That's the reason I always use the word called hybrid programming language. Go is kind of a hybrid programming language. Why hybrid? It has its own paradigms. Okay. It has its own way of doing things. You need to adapt to that. Most of the challenges many people face with respect to Go is people who are coming from Java or Python and all, they try to write Java like Go. They write Java in Go. They write Python in Go. It is not like that. Go has its own way of writing applications. You need to adapt to that particular way of writing applications. We will discuss about it. So, is it compiled? As you already told, it is a compiled. We will discuss about compilation as well. One of the best features of Go, how many keywords are there in any one of the programming language you are using? How many keywords are there in Java? How many keywords are there in Rust? I work in Rust as well a lot. How many keywords are there in Python and so on? You pause for a moment to understand, to count, or to remember, recollect how many keywords are there. And you know what is a keyword. I don't need to say what is a keyword. It's a buzzword. It's a reserved so that the system does some special task whenever it sees a keyword. I have been using Go since 2012. That means almost 13 years I have been using Go in and out. Okay, you can see my repositories also. Public repository itself, there are, I think, 200 to 300 repositories are there. Private repositories working on agents, working on CLI, platform engineering, there are almost 40, 50 repositories are there. Okay. One good thing that really impressed me is the design of Go. The design of Go is very meticulous and fantastic. The reason is there are 25 keywords in Go from the inception till today. You see that generally keywords programming language for every major version they release new keywords until it is stabilized. C Sharp used to add a lot of keywords. Even Rust uses a lot of keywords. Even the latest edition of Rust, they come up with a new keyword because they find that there is a use of keyword. But for the past 15 years, ever since, as I know that ever since they publicly released open source Go in 2009. Though they started in 2007, they open sourced it on 2009, December or November. Till today, there are only 25 keywords in Go. What does it tell us? The design is very stable. They designed in such a way that these 25 keywords, they looked at the future and then understand Go that with these 25 keywords, the entire programming language can do wonders. That was actually what happened. Neither no new keywords are added nor deleted, not even reserved. They keep some keywords reserved keywords, but they have not reserved any keywords for Go. So we're gonna discuss these 25 keywords. Okay, during this session, during our sessions, 25 keywords are very small number, but with this 25 keywords, Go does wonders. So stable design with a minimum uh, modifications. Go does forward compatibility as well as backward compatibility. Most of the Go applications. I recently, 3, 4 years ago, I just wanted to test. I write a basic Go application. I used to know that what version what got delivered. I create two things I have done. I took my 12-year-old Go application, which was written in Go 1.5 or 1.6 version. I compiled it on Go 1.25, 1.25 version. It compiled. I took a program that was written in 1.25 version. I compiled it using the very old compiler. That means 2012 or 13 compiler, exactly compiler version, I don't remember. And interestingly, without a single line of code modification, it compiled. I'm not saying 100% it would compile in every case because new features got added to Go. Collections came into the picture, and then there are certain things got changed in Go, but still it compiled. When I did not use generics, not sorry, not collections, generics, when I did not use certain latest primitives, the core concurrency related application without any latest features, it compiled the latest program which was written in 2024 or 25, successfully compiled against the Go version, Go compiler, which was 1.1.9 or 1.4, some version. It successfully backward and forward compatible. However, backward compatibility doesn't matter for us, but forward compatibility is what actually which is very important. So any program that you write in older versions of Go, it would 100% compile in the latest versions of Go. Okay. There may be little bit of changes because I have not tested each and every version, but the documentation say that you can compile. There may be little changes. As far as I did, it compiled very well. So very stable design. They could see the future of Go and then designed Go almost 1.5 decades ago, which is one of the features. Even though we don't call it stable design, is not a feature. It's a design decision, architectural aspect of it. But still, I feel it like a feature. You can go to any versions of Go and then compile Go applications. Right. So you can understand 25 keywords, stable design. And why people started liking Go, you know that Java or C++ looks quite complicated. Generally, if you really look at C++ application, it is a lot of clumsiness is there. So many pointers. There is a clear difference between references and then pointers. You can create pointers to the pointers. You can pass functions as a functional pointers. There is a multi-level and multiple inheritance, which is very, very complicated in C++. I still remember working for one of the applications back in my initial days of my career. We used to print out the the object-oriented map of certain libraries, Kaspersky libraries, we used to writing some antivirus application. We need to stick to our desk and then understand the relationship between the objects. Very, very complicated. But Go way of doing things is simple. I put simple and stable design. You really look at it. What is a simple programming language that you do? See, obviously Python. Python is used by scientists. Python is used by mathematicians. Python is used by even doctors. Don't be surprised. Python is used by doctors as well. Recently, I gone through a conference where doctors scans they use scans. So they are using Python, to use some kind of a machine learning models to go through the scans. Okay, so Python is used by it is being used as a calculator. Why it is? It's pretty simple. The simplicity of the Python and the performance of the C++, okay, are not exactly the same performance, but near performance of the C++ or have been brought in Go. If you ask me why Go, yes, this is one of the reasons. Simplicity of Python. Go applications are very easy to read. Obviously not like Python, but kind of a Python simplicity they brought. And then they also brought the performance which is nearly equal to C++. Does it really beat C++? In some cases, not all cases. Okay, that is what a simple and stable design, which is what one of the best features I like of Go. So, coming back, Go has a garbage collector. You know what is called garbage collector. Before going to know about garbage collector, you need to know many things with Go. I mean, today's class is kind of a little bit of theory. You know that we will discuss all these things while coding as well. There is something called uh, dangling pointer. There is something called memory leaks. There is something called reuse reuse a pointer which is already free. There is something called null reference. In Go we call it as a nil reference. There is something called double free errors. There is something called data races. These are very common errors and some of them can be solved by garbage collector. Why garbage collector? You allocate some memory, but you have to deallocate the memory. If you forget it, it would become a memory leak. Okay, so Go handles that by using a garbage collector like Java, C Sharp, and Python. All this, except C++, and then except these three, all programming languages use garbage collectors. Does Go use garbage collector? Yes, Go uses GC. But what is the problem that it got to solve? One of the problems with garbage collector we will discuss later on in depth. The problems with garbage collector is garbage collector gives degrades the performance of your application because of passes. You know, you might have heard something called stop the world algorithm. Okay, mark and sleep algorithm, stop the world algorithm. Stop the world means whatever the other work that it's being used. Let us say that we are inside a room, we are working. Someone comes to clean the room. Generally, what we do is, if the room is pretty small, somebody is trying to clean the room. Maybe they were sweeping the room and then mopping the room. What we do is we get up and then we move away from the room. Same thing happens even with the garbage collector. What garbage collector does is, whenever something has to be swept in the room, in the memory, that means looking for the objects which are supposed to be cleaned. The application stops, the runtime stops the actual work, and runtime gives the highest priority to the garbage collection, mark and sweep, or stop the world. Stop the world is the algorithm. It stops everything what is being processed, and then it marks and sweep. That means Generally, Java applications for every second, 200 to 300 milliseconds, Java applications, it stops the processing of your application for every 100 to 200 milliseconds. It's a number that depends on what exactly you're doing. I'm just giving a vague number. Sorry, I'm just giving you some number, but it is generally 100 to 200 milliseconds. That means in 1 second, 10 to 30% of the time that is precisely given to garbage collector. That means you are getting 10 requests per second. Each request takes 6 seconds to complete. That means 60 seconds, for example. But it doesn't complete all 10 requests that hit your application because within 1 second, the 30% of the time is taken by garbage collector. That means 1 second, 30% means 300 milliseconds are taken by your garbage collector. That means your application can really process only 700 milliseconds. Whatever it can do in 700 milliseconds, it does. So what happened is the garbage collector creates latency. It creates latency. The more the latency is, the slower your application performance is. Latency means the time takes to complete each and every task. Why it takes higher latency? Because it stops processing. This problem is solved by Go using low latency garbage collector. Go uses a low latency garbage collector. But there is something called high throughput. It's not just the low latency is very low. We cannot consider it as a good garbage collector. A good garbage collector should have low latency and then high throughput. Comparatively, Go has got moderate to high throughput. Simple thing. If a car manufacturing company, let's say there is a company in Andhra, the Kia company, they manufacture 100 cars per day. For example, they manufacture 100 cars per day. 100 cars per day is called as throughput. To manufacture each and every car, they take 12 hours. The 12 hours to manufacture each and every car, we call it as a latency. Okay, the latency should always be small in number. So I already discussed what is the latency of your Java application in general. Java application latency is for about 100 to 300 milliseconds, case to case based on the application. What is the latency of Go applications? It is less than 1 millisecond. Initially, it was less than 0 to 10 milliseconds. Now, recent versions of Go, they created a garbage collector, which they call it as a green tea garbage collector. Okay, they have created something called green tea garbage collector. It's an algorithm. Earlier, they used to as tricolor garbage collector. These are the latest versions of garbage collector. This garbage collector is very good. This is even better. It drastically brought down the latency to less than 1 millisecond, which is these are all concurrent garbage collectors. We will discuss about this as well. What all the problems that collector is going to see, how do you tune your garbage collector, can you off your garbage collector or can you give specific amount of memory to the garbage collector? These things we will discuss little later. These are all the settings. But just trying to explain you what is called garbage collector and what is going to do. Right. Efficiency or performance. Go is very famous for the high performant applications. Do they really perform like C? Obviously no. But when you really look at all, see, if anyone is talking about performance, okay, you just compare fruits to fruits and vegetables to vegetables. You cannot compare the performance of Java with C language, which is not correct. That means you are trying to keep a race between a person who is traveling in a flight with a person who is, you know, going on a motorbike. That much of difference is there between C and Java. So when you look at the performance, you always try to look at the performance of all garbage collected programming languages. What are the garbage collected here? Java, C Sharp, Python, Ruby, Clojure, and Haskell. These are all garbage collected. Go definitely outperforms all these programming languages in 90% of the cases. Maybe Java is there for the almost for the 30 years or more. So Java might have fine-tuned a lot. So in some cases, Java can outperforms Go. But generally, out of 20 benchmarks, 15 plus benchmarks, Go perform very well. You can look into benchmark games, benchmark related statistics in internet. You can understand. Majority of the benchmarks Go outperforms Java, C Sharp, obviously Python, Ruby, and all. And Go give near performance of C++. Near performance of C++ means it is not going to beat C++ for sure because C++ is designed to be high performer. Okay, but near performance means the statistics, the numbers that you see if you write an application in C++ and then if you write an application in Go, you can see the numbers. The difference between C++ application and Go application is very, very minute. It is in sub-milliseconds. Maybe in some cases, maybe in milliseconds, but the milliseconds are not 100 or 200, maybe less than 2, 3 milliseconds. But with respect to computing, millisecond itself is very big number. That's fine. When you look at the difference by performance between Go and Python, the use case of Python is entirely different. Nobody think about Python's performance when they write about Python application. Python is a very bad performer. You know that Python threading is different. Global interpreter lock, GIC is there. Okay. Python way of doing things is entirely different. It heavily uses heap memory, so that heavily garbage collector has to work continuously, rigorously. So Python performance, Go performs almost, okay, 10 to 100 times than Python. 10 times itself is a very big number, but I'm talking about 10 to 100 times. Again, it is case to case. But Python, something is done in Go by 10 milliseconds. It takes 400, 300 to 400 milliseconds in Python. You can understand. The difference is huge. But Python is pretty good in some other areas. Maybe machine learning algorithms and all. Python has matured a lot. Okay, I'm not saying Python is bad. I'm telling with respect to some applications where the performance is pretty critical, people don't use Python. They use Go or they use maybe C or Rust or C++. If they want to have programming applications that has to protect the memory, then they should not have memory leaks and etc. Then they may use Go. They say that no, our engineers are pretty confident. They have been using C++ for years and all, or C language for years. They may go with C and C++. Our latest we are doing with Rust. But this is the performance. Go performance is top notch. Better performer when compared with all GC languages. And then coming to the most important part of Go. What is that? Concurrency. This is the area where we will spend a lot of time in Go as well because when you write real-time applications, you have to emphasize a lot on concurrency. Concurrency is not parallelism. Okay. In Go, concurrency is a first-class citizen. Why it is a first-class citizen? Go uses something called CSP. CSP is a paper by a scientist called Tony Hoare. Tony Hoare also created something. I'll talk about it. Communicating sequential processes. It It has implemented something called communicating sequential processes. If you want to know that every day we use an application, without that nowadays even we cannot live. What is that app? Mobile app. What is the app that we cannot live in without that particular app? WhatsApp. I think I want you to speak as well so that we can have a better discussion. Something called WhatsApp. Without WhatsApp, you cannot live nowadays. It has become like that. So WhatsApp used was created by using a programming language, something called Erlang. Erlang is created by Ericsson. Fortunately, I had an opportunity to deliver a training for some of the members in Ericsson who also works or modify, upgrade Erlang. Erlang is the language. Erlang. Erlang heavily used CSP. You can understand what kind of concurrency that is required. And you know that concurrency means doing multiple tasks. Parallelism means doing multiple tasks at the same time. The difference is at the same time is what parallelism. Concurrency means doing multiple tasks. Now somebody is juggling ball. They know some people juggle two balls. Some does three balls. Some does four, five, six, seven like that. Right, up to seven balls. Many people does that. When if you go to circus and all something like that, specialists to juggle balls or something kind of a bars, which is nothing but concurrency because they have only two hands. Still, they juggle with multiple objects, which is called concurrency. What is the relationship between WhatsApp, concurrency? WhatsApp uses Erlang. Erlang also has implemented CSP, communicating sequential processes. This is very important. You know, this communicating sequential processes was written in 1980s or even before, maybe 78 or 82. Exactly, I don't remember the year, but it is late 870s or early 80s. You see that there were no even multi-core processor. Forget about multi-core. There are not even proper processors in 1980s. But Tony Hare has written a paper, white paper. You can download that as well. Tony Hare CSP that has explained clearly that how concurrency has to happen, communicating sequential processes. The processes run sequentially, but how do you establish communication mechanism, maybe something like channels or pipes, so that the communication would become seamless communication, which is what actually the concept of CSP talks about. We will discuss about that in the future sessions. So one of the first class citizens, concurrency is the first class citizen in Go. Concurrency is first class. So whatever you do, many companies they use Go for the better concurrency. They use Go for the better concurrency. They want to have the best concurrency, so they use Go. This is where exactly we have to focus a lot while writing Go applications. Concurrency is not parallelism, remember that. And concurrency is not always about putting a lot of stress on your CPU. So again, we will discuss about two different ways of tasks that we do with respect to applications. CPU heavy applications and then IO heavy applications. IO heavy applications means a lot of input output operations are there. Generally for high IO heavy tasks, we use async await kind of asynchronous programming in other programming languages. Okay, CPU heavy, they use threads. But in Go, you don't need to worry about whether it is a CPU heavy or it's a IO heavy. You just need to write Go routines. They handle themselves. They have the intelligence to understand whether it is CPU heavy or IO heavy. Based on that, it works. Okay. Concurrency is one of the things. And what else? We talk about simplicity, we talk about performance, we talk about concurrency. So open source, obviously it's a open source programming language. Compiled, Go is a Go is a general purpose open source programming language and all. What else? Okay, coming to the something. One thing you need to understand is Go is compiled and also statically typed. It looks pretty simple, but it's very important. Statically typed means every variable that you create in Go should be known to the compiler. Unlike Python or JavaScript, Ruby or even JavaScript, every type that you create in Go, you know that there is something called statically typed versus dynamically typed. Dynamic type means a type can be created even when your application is running. But statically typed means the data type should be clearly known to the compiler. A type should be known to the compiler. A type should be known to the compiler during compilation. Go is statically typed programming language. And one of the best thing about Go is the runtime. Go has garbage collector and Go also has the runtime. Simple thing. I want to run my Java application on a MacBook. I want to run Java application on a MacBook. What do I need in order to run Java application on a MacBook? I'm just asking, what do you need in order to run Java application on a MacBook? I want to run C Sharp application on a MacBook or on a Linux machine. What do I need? You need to install JVM. You need to install Python maybe runtime. You need to install C Sharp runtime, .NET runtime. Here closure you need to have JVM, Python runtime, Ruby runtime, JavaScript runtime, which comes generally with browsers. Nowadays we are also using V8 engine or Chakra engine or Node.js, which also become a runtime. The runtime to be installed on the target machine. But Go has got a runtime which is embedded into your binary so that you don't need to install Go runtime on a target machine. You don't need to install Go on the computer that you are running your application. You don't need to install Go. You just need to use Go. You create a binary. I will show you. Just drop the binary, which we call it as Go produces static binaries. Static binaries are the binaries that are produced so that not depending on any specific operating system, not depending on runtime, neither depending on the operating system related libraries. Go produces static binaries. That means you just drop the binary. That's all. You don't need to worry about whether the binary would run or not, whether the internal libraries are related there or not, or you need to install any specific runtime. No, nothing is required with Go. Go does the cross compilation. Cross compilation. Cross compilation means Go supports you are on MacBook, you can compile it to Linux. You are an ARM processor on MacBook, you can compile it to Windows AMD 64, vice versa. Go supports so many so many platforms. For example, Go tool, dist list, I will talk about it. Go tool dist means these are the operating systems and these are the chipset. Okay, Android and then 386, which is old Intel, Android and AMD 64-bit, Android and ARM. Similarly, you can see NetBSC, OpenBSC, Plan 9 applications, Solaris, Windows, Linux, various versions of Linux. You can also see that, uh, you know, IBM machines of Linux, S400 kind of versions, MIPS, MIPSEL, MIPSEL 64. These are all the operating system and then the processor version. You can do the cross compile between all these things. Let's say I am on MacBook. I can compile to this. I can compile to this system, Dragon or Dragonfly system. I can compile even to iOS. iOS restricts is a different problem, but you can technically write applications that would run on your mobile devices using Go. But the problem is iOS doesn't accept uh, binaries that are coming from outside. Their security processes or policies are pretty strict. Cross compilation is one of the best things of Go. And then Go produces statically linked. What is called linking process? If you have ever understand about what is called linking, linking is, let's say that I want to open a file in Java. I want to create a thread in Python, for example. I'm just giving you some examples. It is not your Java that creates the thread. It's not the Java or Python that opens the file. It is all about your operating system. Java, your JVM calls the libc library. Libc is a standard library. There is something called Musel. There is something called glibc. Different operating systems use this different. On Windows, it's different, but it would call a system library, which is a mediator between your operating system and even your low-end kernel. The communication happens between that by using a library. So whenever you run Java applications, your JVM would always look for where is the library in that particular system. It's very hard because there are any incompatibilities. Application would fail to run. That's the reason that is the reason Java does the just-in-time compilation. Just-in-time compilation means after Java bytecode is loaded into JVM, and then JVM does the compilation based on that particular machine on which it is running. But the libraries are not statically linked. They are dynamically linked. But that means based on the operating system, based on the system, it would look for the libraries which are there inside the system. It uses those libraries. Is it good? Yes, in a way it is good because dynamic linking is in a way it is good. It would reduce the size of your binary. But it comes with a lot of baggage of problems. So what we do, what Go does is statically link. Statically linking is a process. I will explain it. Linking is a separate process. Statically linked means Go applications are linked in such a way that it it embedded that particular library which is created by Go, not the whole library. libc is maybe for example 10 MB. For example, Go doesn't include 10 MB. Go creates its own library which is compatible with libc. Let's say I'm trying to open a file, but I'm not using any network application. Go doesn't include the libc kind of, which would create network applications, which would create maybe the different system calls. It 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 allocates it sorry it creates it links only a library that is designed to open and close a file. So statically linking is a wonderful process. Actually, looking at Go only, Even there is a programming language called Zig. It has becoming very, very popular. I use these three. I used these three. I used this one and this one. I use Clojure a little bit, so I know the difference very well. Zig is a programming language that they really wrote everything like a statically linked. They got influence from Go. So statically linked means libraries are linked into your binary. Binary is nothing but executable, which we call it as a statically linked. So what is the benefit of statically linked? Go applications are fast startup. Particularly, you see that serverless applications, applications are cloud native applications can be cloud native application development and all. What is called cloud native application development? Cloud native application development means applications can be designed and developed to utilize all the features of cloud. People claim that Spring Boot is cloud native. In fact, it is not. C Sharp is cloud native. In fact, it is not. It is not about running. It is about efficiently utilize the cloud resources. Let's say that serverless application. Serverless application means the application would be in hibernation mode. Whenever you send a request, the application would immediately start running. It starts the application, it compiles your application, start the application, start running. If you take an example of serverless. But in order to compile, start, it takes little time, maybe few seconds. Seconds are very big in numbers with respect to computing. We talk about microseconds and milliseconds. Something that goes to seconds. Second is a very big number in computing. So, because of statically linked libraries, Go's startup time are very, very blazingly fast. That is the reason people prefer Go for their cloud native microservice application development. The reason is they can deploy Go applications as a serverless applications. They can deploy close Go applications. They can scale up and scale down the number of instances of the application very, very rapidly because the startup times are very, very minimal in milliseconds, less than millisecond. I'm talking about millisecond means yes, 1000 milliseconds is a time, 1 second. When I say in milliseconds means I'm talking about sub-milliseconds, which is 10, 20 milliseconds, etc. It's a very good number. Okay, this is something. You understand this. And one of the compelling feature of Go is fast compilation. This is many people say that this they use Go because of fast compilation. You know that compiled system programming language, GC, simple and stable design. I put it as a fast compilation. Fast compilation is one of the best features of Go. Go compiles blazingly fast. There is no other programming language. I think Zig nowadays they claim it, which can compile, but it is not even stable. Not even version 1 is released, which can compile as fast as Go. You know, I still remember in 2010 or 11, my initial days of the career, I write application uh, in Java. I compile the application because I want to create the build, a jar file. I compile and then build the application. I go outside, have some tea, do pep talk with my friends and come back. Still, it might be compiling. It used to take 20 minutes to compile and build the application. But do you think that 20 minutes is a valid number? 20 minutes is a very big time. That is one of the reasons why Go created. Actually, if you really look at it, why Go was created, one of the main reasons that Rob Pike told is fast compilation. At YouTube, in Google, They cannot wait for minutes and minutes just to compile an application. They want blazingly fast compiler so that they created Go. One of the reasons, one of the design or decisions of Go is fast compilation. Other than performance and concurrency, one of the best design decisions they focused using Go is fast compilation. Why it compiles is a different thing. I'll talk about it. Okay. So let's just talk a simple Hello World application before going to leave today. We just create a simple Hello World application, compile it, create a binary, and then we can close the session. And then tomorrow onwards, we will be speed up our applications. So I create. So you just need to create a directory. You just go inside the directory. First thing in Go, what whenever you create Go application, you need to create a module. That's very, very important. Module is the virtual path of your application. So I create a module, Go mod, init demo. I give the name of the module as demo. The moment you create a module, it creates a file called go.mod. You can see that. You can see that there is a module name as demo. So what I did is I created a directory. I went inside the directory. I initiate it as a module. This name is very important. I will discuss about this little later, but right now we give only as demo. Now I create a file called main.go. So main.go is the file. In main.go, I create a package called main, function as main, and I write print line as hello world. Hello Golang Go learners. This is your very basic bare minimum Go application. It has to be main. I'm sorry. So the entire Go system is based on packages. Package main means you're telling that utilize the main package. I'm sorry, going to use main package, which is predefined and also known to the compiler. It's not your own package, it's a main package. And function main is the starting point as of now. Why I said as of now, there are little things I want to discuss, but you can think it as this is the starting point. Main function. You observe that there is no int main, there is no main int, there are no command and arguments and all. I'll talk about it, why it is not there. Print line is a built-in function. So there are keywords, there are built-in functions in Go. Print line is one of the built-in function. Built-in function means you don't need to create a function or call a function through a package. I will talk about this. So I create a file called readme.go. Sorry, readme.md. I'm sorry for that. It's not readme.go, readme.md file. So what you do is you create a directory. You go into directory and probably so you create a Go application and then you go into that application. You create a module, Go mod init demo, the name of the module, and then what you have to do is go run main.go. So what go run main.go does is go run main.go does is compiles links, assemble, and links so that it generate a binary. I'll explain this process. It compiles your application, it assembles your application, and then it links your application, and ultimately it creates a binary. That binary is getting run here. But where it is creating binary, it creates the binary in a temporary location. This is the location a binary is created. You want to see, you can go to this particular location on your machine. The binary is created, and then it automatically runs that particular binary. To see the binary where it creates, you can do that. To know where the binary is created, you can run the with a something called work. So what exactly this means? Sorry, what exactly this means is you create an application. Let us say you can also create like this: go run dot. It would automatically pick the main package files with respect to main package. You don't need to tell go run dot main dot go. You just give go run dot dot. Can also give go run dot dot. Dot talks about to go and then collect all main files, all the files that are related to main. Main is not necessarily to be main.go. You can give any name of the file. Let's say I can also rename it as demo.go. Not necessarily, but this name is very important. This function name is very important. Let's say go run, it runs. Let's say go run demo.go, it runs. Not necessarily to be main.go, unlike Java or Rust. Okay. Even C++, it doesn't care about the extension also. That's a different thing. But just giving you some kind of an example. Okay, we will speed up from tomorrow onwards. Just want to give you a clear picture about what exactly, why are you going using Go language? What is the difference with respect to different programming languages at a high level? What are the features of Go? So all these features we will go on then explore one after the other in the upcoming sessions. Okay. So maybe a little bit of boring because of the theory, but unless until you really know that what exactly Go does, you know, what are the features that Go provide, you really can't even uh, do kind of a research while working on Go. We know what Go does, you know the capabilities of you have a knife, a Swiss Army knife, you should know what all you can do with the knife, why, where it is specializes, what are the specialties of it. Then only you can use it as a toolkit somewhere. Similarly, when you know that what all Go can do, obviously you can do better. Systems programming language, what systems you gonna do? Create statically typed, what is the benefit of that? Okay, let's say garbage collector, we will see what are the benefits. Performance, we look at the performance, we can go and then see how the performance. Cross compilation, we will compile our application to different platforms. The runtime, which is embedded, you don't need to install a separate runtime in order to run Go application. You don't need nothing, you need nothing on a target machine to run Go applications. You just need a binary that is created in Go. But you don't need to install JVM kind of, you don't need to install a runtime, you don't need to install a virtual environment like Python, nothing is required. Everything we will look into one after the other so that automatically you will understand, okay, this is what the facilities that Go got to provide. Okay. Okay, that's all for now. Any questions you please do ask. Uh, Otherwise, yeah, we can quit for today. I'll post it inside Google, sorry, YouTube, as a private thing. You please provide your email address, Gmail, so that I can give you the access to that. And GitHub repository link is also given in the chat. Any questions you are free to ask. Otherwise, let's jump into the tomorrow session where we start investing our time into many features of Go. Thank you. The learning is quite initially slow, but and it reaches a point where we use multiple things. So please be patient. Let's say that no, we want to learn in advance. I'll also share the my other YouTube channels of Go, whatever I have delivered. You can also follow that as well if based on your interest. Okay, there is something called Go for absolute beginners. Uh, you know, Go from basics to pro, Golang batch 3. There are so many things. Kafka using Go. You know, there are so many things. Go for personal training, etc. There are so many things are there. I can give you the access to those videos as well, so that you can go through. And one more thing is my every session I explain differently because I don't come up with a template based explanation. I'm not a great fan of that. I always try to explain in a flow. I make sure that nothing is missed. That is something, but I explain with a flow. That is how I really feel that the explanation would be pretty good. If you go for a template based application explanations, let us say that I have some documents, slides. I can share you the slide where I will explain Go language. Golang microservice general presentation. Somewhere I'll give you programming in Go. Very long ago, I used to open this and then explain, but later on I understand that this is not that great way of explanation. I'll copy you. I will copy this and give it to you. There, I explain through the presentations. Okay, you can still go through and then explain that. You can go through that. All the examples are given. It's good as well. I'm not saying it's bad, but yeah, we will go through that. I can give you the link. You can go through that. A lot of presentations are there. You can see that almost 93 presentations are there. Okay, you can do that. No issue at all. Okay, but this is just for your reference. I'm not going to. Okay, I'm not going to explain this way. Okay, thank you very much. Have a great day ahead. Yeah, please ping me if you have any questions anytime. You're free to ping me. I would explain things. If you don't understand, let us say I say that statically typed. If you don't understand, yeah, please let me know. If you say linked libraries, if you don't understand, yeah, personally also I can speak to you to make you understand. Maybe certain things I may not be able to cover with a time constraint, but if you're stuck anywhere, please ping me. Once I'm free, then I can be able to explain you very clearly, more clearly. Okay, thank you.